Allô tout le monde, on va commencer tranquillement pour rester sur l'horaire. Donc, I'm going to do my little introduction bilingually because we have a lot of people in the room, but there's also a lot of people on Zoom. So I'll start with French and go to English. Bonjour à toutes et à tous. Je suis vraiment très heureux aujourd'hui d'accueillir un invité spécial pour une conférence que j'essaie de faire chaque année, un peu de mon initiative, la conférence du président, pour aiguiller un petit peu sur des sujets plus que pertinents. Donc aujourd'hui, je suis vraiment heureux de cette première conférence-là de l'année. Puis aujourd'hui, c'est une conférence où on reçoit une rockstar vraiment. Une rockstar dans son domaine, clairement, parce que Hugo, c'est vraiment quelqu'un qui est vraiment très, très important dans le domaine de l'intelligence artificielle. So, good morning, everyone. I'm really delighted this morning to open this conference of the president on a topic that I think is touching all of us. And it almost feels like we're receiving in our walls a rock star. And in fact, in the AI world, Hugo is a rock star. Maybe you won't agree with me, but... Sur une autre note, Hugo vient juste de prendre la direction scientifique du MILA. Le MILA qui est un des instituts d'intelligence artificielle les plus importants à travers le monde au complet. Il succède des gens très importants, entre autres Laurent Charlin qui a fait un intérim assez court, mais surtout, il prend la relève de ce que Yoshua Bengio avait initié au MILA. Donc, c'est vraiment un poste très important pour l'université, mais aussi pour la société. As many of you know by now, Hugo has just taken the helm of the MILA, one of the most important AI institutes around the world. He's following up in the footsteps of very important people, including Yoshua Bengio, who has been instrumental in shaping up AI as we know it today. Le parcours d'Hugo est vraiment impressionnant. Il a été justement formé par Yoshua Bengio, mais aussi par Jeffrey Hinton, qui est un autre expert de l'AI, un père du domaine. Puis par la suite, il a pris des postes à l'Université de Sherbrooke, mais aussi il a parti sa propre start-up, WetLab, qui a été achetée par Twitter. Puis il a travaillé pour Twitter après, donc il a été vraiment instrumental pour implémenter des concepts d'AI chez Twitter. Puis par la suite, il a été approché pour venir diriger Google Brain ici à Montréal. Donc il a développé Google Brain à Montréal, où il a travaillé jusqu'à assez récemment, avant d'être nommé là, récemment au MILA. Donc, the journey of Hugo is really remarkable. He trained with two of the field's father, Yoshua Bengio and Jeffrey Hinton. And now he's an assistant professor at the University of Montreal. He's recognized for major contribution in deep learning, some words like denoising and autoencoders, autoregressive modeling, which is machine learning and neuronal networks, I think is his expertise, if I vulgarize it. He also started his own startup, WetLab, that was acquired by Twitter. And also, he opened the Google Brain initiative here in Montreal that he led scientific aspect for many years. So, I'm almost done. Au-delà du scientifique, Hugo comme scientifique, Hugo est aussi un homme engagé. Il est initiateur de la conférence Tech Aid au profit de Centraide. Il est un donateur actif pour soutenir la relève étudiante à l'Université de Montréal en particulier, mais en particulier pour la relève de l'intelligence artificielle. Mais aussi, il y a une vision, je pense, que pas beaucoup de scientifiques ont, qui est autant engagé du côté scientifique, du côté entrepreneurial, mais aussi du côté sociétal. Donc, je dois dire que c'est assez rare qu'on a la chance de voir ça. Beyond the science, Hugo is a deeply engaged individual. He launched the TechAid conferences in support of Centraide and is an active donor supporting the next generation of AI researcher and AI researcher. He embodies a rare combination of academic excellence, industrial vision, and the societal commitment. Aujourd'hui, j'ai invité Hugo à présenter cette conférence-là à l'IRCM parce que je pense qu'on doit tous réfléchir ensemble à ce que signifie l'essor fulgurant de l'intelligence artificielle. Est-ce qu'on doit en avoir peur? Je pense qu'on est beaucoup qui en ont peur des fois. Est-ce qu'on doit l'embrasser? Est-ce qu'on doit la mettre dans nos pratiques personnelles, nos pratiques professionnelles? Donc, je pense que ce n'est pas Hugo qui va nous dire quoi faire, mais je pense qu'en écoutant Hugo puis sa vision sur le sujet, ça va sûrement nous aiguiller puis nous préparer à cette transformation importante-là. I invited Hugo today because at the IRCM, I think we must reflect on the fast progression of AI in our daily lives. And all the questions that every one of us is asking: should we be scared of AI? Should we embrace it? Is our job in jeopardy? And all these type of questions. And I think that having Hugo with us today to give this inaugural conference for this year is really going to be helping us to reflect as a community and decide how we move forward with AI at the Institute and in our personal life. I was also told that there's going to be translation through a little app that you have scanned the QR code at the front. So this is there. So without further ado, I'm very happy to welcome Hugo and I give him the stage for the next hour or so.
Merci beaucoup pour l'invitation. C'est des mots très généreux. Je n'en demandais pas autant. Bien heureux d'être ici pour cette présentation. C'est la première fois que je la donne. C'est un peu une demande que j'ai reçue de parler du sujet de l'intersection entre l'IA puis la science de façon générale. Puis la commande que j'ai eue, c'est quelque chose qui est quand même aussi accessible à un public assez varié. Donc, j'ai fait des ajustements, j'ai ajouté du mot matériel. C'est un sujet qui quand même m'intéresse d'un point de vue recherche. J'espère en faire plus également. Mais je risque de rester quand même assez haut niveau. Donc, si jamais vous voulez pousser plus sur un sujet, vous pouvez m'interrompre pendant la présentation. Ça va me faire plaisir de m'ajuster et de répondre à vos questions. Ou évidemment, vous pouvez me les poser à la fin également, mais pendant, ça me convient aussi. Et puis, bon, on m'a dit de faire la présentation en anglais, donc c'est ce que je vais faire. Alors, the main question that I'll try to focus on is this question here. So whether AI can be a scientific assistant. And so I was mentioned, I'm the scientific director at MILA now, and I'm interested in that question because it has AI in it and because it has science in it. And obviously at MILA, you know, the core of everything we do is scientific work around AI, developing AI, understanding AI. So my other interest for me personally, somewhat selfishly, is also I think we could use more assistance to help us do better work and move our work faster. And I hope some of these topics that I think will also touch the type of work that's done here will be useful, thought-provoking, and happy to discuss some more. Okay, so roughly what we'll talk about, well, we should discuss what is AI very briefly. Seems like a simple term, but I think there's a lot of ways of understanding what that means. And hopefully I can sort of give you some intuitions for why AI works at all. Then I'll talk about some of the uses that I make of certain technologies in AI in my own research or my research workflow. Then I'll talk about peering into the future a little bit. What are some of the more bleeding edge projects that exist that is trying to push AI in science in some even more ambitious directions, to give you a glimpse of what we might see in the future. And then I want to end by just discussing a little bit, well, what are the parts of our scientific workflow that are appropriate for AI, which is largely an open question, something that we'll all be deciding more or less in the way we decide to adopt it. So that's the plan. All right, so what do we mean by AI? We'll start with something fairly basic, but please, interrupt me if you want me to clarify some aspects here. Well, we can't talk about AI, artificial intelligence, without clarifying what we mean by intelligence, which is itself like a question that's not trivial. Many people might have different definitions for it. So we can start by our own intuition. I think a lot of people think of intelligence as like what we need when we're at school. I think oftentimes, sort of intuitively, we think about topics like math or just abstract reasoning as requiring a form of intelligence, and that's definitely within it. But in AI, we'll often think about just generally the ability of solving problems. And really, that will sort of cover everything that we learn, all the capabilities we acquire from when we're born to becoming a kid to becoming an adult. So that will include things like being able to understand what I see, being able to communicate with someone and convey information, being able to hear and understand the sounds around me, but also manipulating the world around me. So being able to pick up an object and pass it to someone else. So that will include also aspects of what we do when we play music or write music. So all of that really is considered being covered in some way or another by artificial intelligence. And our goal is to find a way of implementing these capabilities in a computer. All right. So that's what we mean by AI. AI is a pretty old field, many, many decades of AI research. And what AI looks like today is also quite different from what it looked like, say, 50 years ago. Approximately, you could say that the sort of older version of AI was an attempt at programming a computer so that once you're done programming, it's already intelligent. It's already smart. It can do a lot of things. But this made some progress. We're able to do certain things like that. We could argue that this is roughly how we managed to get an AI that would become world-class at playing chess. But there are a lot of other aspects in life that this approach never really panned out. And the realization in the past, I want to say maybe 20 years, is that a more promising approach is not to program a computer to be smart, but to program a computer to be able to learn to become smart. And to do that, one approach in particular that's been quite successful that the people we mentioned like Joshua and Jeffrey Hinton really pioneered is the notion of taking inspiration from ourselves, taking inspiration from the brain, and to try to take that inspiration, implementing this capability of learning. Okay, so I want to really, really simplify things. To learn, you need two things. You need a brain. So essentially, we're going to need to have some way of implementing a computer, the ability of acquiring knowledge through a form of artificial neural network that has connections and that will be adjusting based on experience. And we need examples. We need data. So bring yourself back when you were at school. If you're anything like me, if you had someone explaining to you a new concept or new thing that you might want to be able to do, immediately, at least for me, I was like, well, can we just get an example? Because with an example, it immediately becomes clear or much clearer. And turns out with a computer, to learn, that's also pretty much true. So in our field, we'll have people that will really try to push how do we add a brain in a computer and what kind of brain, what does that mean for a computer to have a brain? And you have a lot of people that will work on methods for really collecting a lot of examples, so a lot of data so that the computer can train or learn from these examples. So the analogy that I give for the way that computers learn is that there's sort of like a pretty slow but very, very courageous and sort of persistent student. So with each example, it's going to learn just a little bit. But if you give it a lot of examples, it go through all of these exercises, so to speak, and it will do that over and over and over again until it actually sort of is able to grasp and solve these examples. And that's pretty much what works today. So I'm going to, so I'm out of curiosity, who here have a notion of what an artificial neural network is? You just raise your hand. Okay. Not everyone, which is great, because otherwise this demo is completely useless. I should have come back here. I'm going to click here. I'm going to try to make this a little bit more concrete or tangible, at least visual. By going in this demo here, I'm going to train a neural network to solve a very, very simple problem. So here, the question that we ask it is in the form of a sort of horizontal and vertical coordinate in this square here. So for instance, this point here, that would correspond to like -4 and minus, I guess, 2.5. And what the neural network needs to answer as an answer to this question is this a blue dot or an orange dot? Okay. And you can see here the problem is such that the blue is in one spiral and the orange is in another spiral. Okay. And all of these points here, they're the examples. That's what we're going to give to the computer so that it learns to distinguish between these two types of dots. And the way it's going to do that, the brain, it takes these two numerical values, and then it's going to propagate that information into a set of neurons here that are connected with a set of neurons here that eventually goes to a single neuron as output that's going to say, is it blue, is it orange? Here, numerically, blue just means a value of 1, and orange means a value of -1. So when I'm going to start the training, what's going to happen is these connections between these neurons, they're going to adjust. And as they adjust, we're going to see what kind of predictions the neural network is performing in this little square. So we're going to see parts becoming blue and parts becoming orange. I'll just get it started. So you can see the connections here are changing. You can see here some parts are getting orange, some parts are getting blue. This corresponds to what prediction would this neural network perform if you gave it that coordinate at that position. And what you see is that, with some time, and here it's gone over like thousands of times over each of these individual examples, trying to nail it, making a prediction, observing if it's made a mistake, and if it's made a mistake, adjusting its connection so that it doesn't make a mistake next time. I'll just pause it now. And what you can notice is that, well, most of the places where there are orange dots, it says orange, and most of the places where there are blue dots, it says blue. It's not perfect. If I kept it longer, it probably would put some orange here. And that's essentially what training a neural net means. Okay, that's essentially what happens under the hood. One thing just from this example we can already notice is that in places like we suspect there's a spiral, orange spiral that would go here if I had more examples, but it actually doesn't do that. It says blue instead. So already just from this example, we already see that, well, if we get a question that's very different from what it's ever seen as an example when it was learning to perform this task, there's a reasonable chance that it's going to get it wrong, okay? So from that, what's a solution is just indeed collect more examples to fill up these holes, okay? And generally speaking, that's a good intuition when we want to think about using an AI system. Is it likely that this system has seen a question like the one I'm about to ask? If it is, or it's a question that's sort of similar, well, it's probably going to do a good job. If it isn't, well, it's a little bit of a bet. It's possible that it makes a mistake, okay? Any questions about that? I mean, obviously, like, this is just visuals. There's no, I don't think I have any math in my slides. So, but any questions that this brings to mind? If not, and obviously you can ask questions later. Yeah. That's a great question. So maybe one thing I'll mention. So you have these layers here. The analogy for a brain is like different areas of the brain. So it's like maybe this is the retina, and then maybe this goes into part of visual cortex, and then a deeper part of visual cortex. That's the analogy. The most reliable way of doing better with a machine learning system, an AI system based on training a neural net, is to add more data. That's like more or less the only thing that we can guarantee. If you give it more data that looks like the type of questions the system will ask, then it's going to do better. Now, part of the work that someone like me would be doing is indeed sort of play with like, okay, maybe I should remove some neurons here. Maybe I should add some layers. We can automate some of that process too. My startup that was mentioned did that. That was sort of what we developed, is like an AI to optimize an AI at the time. But that would be also like if you're constrained and you only have this data and there's no other data you can collect, then you'd start sort of going into this phase of tuning it and trying to find, does it need more neurons, less neurons, and so on. A very good question. Yeah. Mm-hmm. Yeah. So the software here, I mean, it happens. I think this is JavaScript just because it's running in a browser. What's being implemented is like, some sort of mathematical formulation that takes, to be technical, a linear combination of its inputs passed through some sort of nonlinear function. And you can probably in this demo, yes, here you can sort of change different activation functions that we call and so on. And here, I actually don't know. It might be run locally. I'm not quite sure. But like bleeding edge AI systems, they will be run on like GPUs. So if you hear about NVIDIA and you're like, why is this company so valuable right now? Well, they're producing all these GPUs that everyone is using to train much larger neural nets on tons and tons of data. And their hardware that they're selling is really, really good at that. Great question as well. Other question? For now? Okay. All right. So what I just described, you have a data set, you train some brain, some neural network on some data set. That's a great way of designing a specialized system for a very specific type of capability that you want. And for a lot of times, all the way till maybe 5 years ago, that was effectively what people meant by AI. You would say you wanted a computer vision system, you'd collect a bunch of images, you'd label them, these would be your examples, you train a neural net on these images to map from the image to the answer, to the label that you want to be able to detect. If you trained a machine translation system, you'd collect a bunch of examples of sentences in English and French, and you train a neural net to go from English to French. And you sort of train an isolated system, and it'd be people in sciences, in biology, and in chemistry that would define a specialized problem. There's some inputs, they need some outputs. You collect a bunch of data, and the neural net would sort of take care of figuring out the mapping. And there's a lot to be done with specialized systems still. But what we are seeing more and more now is a type of AI that we call generative AI. And specifically, this is a type of approach to AI that tends to go beyond the specialized systems to something that's actually quite general and can sort of handle a lot of different tasks and is much more flexible. Oftentimes, it's used through some sort of chat interface. So ChatGPT is a form of generative AI. And what this has allowed is really to expand how flexible and easy to use AI systems or AI technology can be. Okay. So in the next few slides, I'll try to bring some intuition as to how this actually works. So generative AI is still AI. So we still need two things. We need a brain and we need examples. Now, the brain here, I'm not going to talk about it too much, but this is an expression you might have heard, which is a transformer neural network. In short, it's a type of mathematical description of a form of neural network that really scales really, really well. So it's able to be very, very big without being too slow and to deploy, to train that system and run it over millions and millions of examples. So that was like one of its key properties, that it is very, very efficient to run a sort of training procedure with a transformer neural network. You don't need to know much more than that, except that this really enables training on a lot of examples. Now, what the examples are going to be. So in this setting, so we want a lot of examples. We wanted to cover a lot of different types of knowledge, of skills. The approach that was taken behind systems like ChatGPT, Gemini, Claude, and all these other ones you might have heard of is to essentially do a pretty simple task, which is to just predict. So let's focus on the example of text. Take a bunch of text and predict the next word given all the other words in this text. So for example, you might take all of Wikipedia, and let's say we consider that page from the Institut de Recherche Clinique de Montréal. Well, the question that might be asked might be, what is the word following? Institut de Recherche Clinique de Montréal, also known in English as Montreal Clinical Research Institute, is a. What is the word that comes after a? Okay, that's in gray here. And so we'd feed all of that context here as input, and then it would produce a guess as to what is the next word. And then if it predicted medical, that's great. If it didn't, we'd adjust its connection. So next time it's closer to that answer. And we continue and sort of predict each word one after another. Okay. So, okay, fine. Like this, the internet has a ton of text. So that is a way of getting a bunch of data for our system. But why does that make any sense? Like it might not be intuitive why this is actually useful. Why do you want a system that can regurgitate the web? How is that actually useful? So these are the reason, the intuition behind this is that the motivation is that we want a model that is good at generating text. And it turns out that answering questions is just a subcategory of generating text. So for instance, if I wanted the answer to the question, what is the Institut de Recherche Clinique de Montréal? well, I could just add as the input of my text generator, what is the Institut Clinique, Recherche Clinique de Montréal, answer, column, and then just ask it to generate what is likely to come next. What is the text that should come after that? Well, the text that should come after that should probably be the actual answer to what was my question. If it's a good text generator, then it should be able to complete that sentence, and that sentence will give me the answer. So that's kind of the key that suggests that when you train on a bunch of text from the internet, it's a good representation of the type of text that people write, then for free, you're getting something that can answer questions. And that becomes on a bunch of topics, as long as they're covered potentially somewhere on the web. So that was kind of the key. And ChatGPT was sort of like the best illustration of that and most compelling illustration of that idea that enables a lot of things moving forward. So now I focused on text, but you can do that with images and with video and with sounds. You can sort of mix having both text and images. So you can have something that answers questions about images. You can have something that takes some text and actually produces an images for that text and so on. So there's one example I like to show. So I'm from Google, so I have a bunch of Google examples. Like there are other systems in Google, but just be warned, like I have this little bias. But here's an example. This is an older system now that will, just to show you that it can be multimodal. So in this case, what it'll do is that it'll take a question that's in the form of both a video, this is an old sort of black and white movie, and then the question is, find a moment when a piece of paper is removed from the person's pocket and tell me some key information on it with the time code, okay? So that's kind of the question. And then we're gonna have it produce an answer for that. And wait a little bit, has to wait because there's a lot of information in that video. And it says at 12:01, there's a piece of paper, there's a date on it, 10/23/1924, and an amount of $4. And if you move in that video at about 12 minutes, indeed, that's what's going on. There's a piece of paper with that information, okay? And that was achieved by training, certainly not just on text, but also on video and so on. Now, there are more details as to how you get to that, but that's the gist of it. You know, those are the main components if you want to understand why this works at all. Any question on generative AI in general and what I've just shown? Yes, no, yes.
Fail to trust some kind of information as opposed to others, because we kind of discourage people to go self-diagnose on the internet or whatever.
Yeah.
I'm like curious to know, how is this, how can we trust it?
Yep. So a lot of that, the answer to that question is what examples were provided, what were the texts that were used for training and so on. A lot of the sort of corporate secret around how to have a good system like this is actually making that choice. And it's a very complicated choice. So, you know, in companies, they'll have long discussions and a lot of experimentation about, okay, what if we put like, this is more an example for my field, but like more code in all of the data we have, or less code, or more data from that source, or less data from that source. And they sort of tinker on some of these ideas until they get, you know, something that generally does well. So that's a first part of the answer. So, you know, are the sources that maybe touches on medical knowledge that is put there? Is there some amount of filtering that's happening and so on? I suspect there is, but you know, this is kind of a corporate secret. And I even when I was at Google, I didn't work on that aspect of it. And even if I did, I couldn't tell you probably. So, but that's one part of the answer. The other part of the answer, and we'll start seeing that later when I talk about some other systems, is that beyond just generating text, we also now have AI systems that will take some action like searching on the web. So if you use like all these systems right now, pretty much they will have a feature that enables it to do a search on the web and finding particular pieces of evidence that will inform the answer. So in Gemini, like you sort of see that very frequently, and they will give you the link to that page. So maybe you sort of want to dig deeper, which is very helpful if like the answer you're looking for is like, you know, what hinges on that is critical or sensitive or whatever. And that is another thing that allows it to sort of really ground its answers in potentially more, you know, trustworthy sources and so on. So that will be the other component that you'll use, is sort of determine, okay, let's allow this AI system to make its own Google searches and see some pages and pick the ones that it uses for its answer, and just determining, okay, well, what are the top ranked results, and are those the most trustworthy? That will determine a lot whether you can trust it. But also you could inspect it. Like if I went in Gemini and did a search, I would see a little icon. I could click, okay, it told me this. Where does this come from? That would be another way of sort of knowing if it's from a trustworthy source. But for instance, certainly I am like 99% sure that behind the training of these models, there's a lot of training on like scientific paper, for sure. And I think that has enabled a lot of some of what I'll be talking about, which is how, why is it that it's useful even in the type of scientific work that we might all share, which is like literature review and things like that. That answer the question? Yeah. Great question. And in the back, yeah.
Sort of a technical question. So what fraction of this data or information that's being used to train AI comes from AI? And is that changing? There's more and more AI-generated stuff out there.
Yeah, so that's a great question. I wouldn't know the exact fraction, but I think there are like two answers to that. So the first one is, I'm assuming that these systems take a new snapshot of the internet, every time they train the next one. Well, obviously, people are using these systems to write content that goes on the internet. So, there is this feedback loop. If, depending on how people are using it, the responsible way of using it is it generates something, and then you read it, and then you correct it, and then maybe you put it out and you share it. That might actually be very good. Like the next generation is going to be an improved version of the previous one because people just naturally will have improved the outputs. Now, some people might not do that. Some people might just take the output, put it online, and not really sort of take a careful look at it. So that is like one thing that I suspect companies are aware of. Sometimes they have ways of knowing whether their own system generated that text. There's sort of ways to secretly insert signals that you could sort of assign a probability and be quite confident that, okay, this piece of text, like it comes from our system. It's like several things where like you'll encourage certain combinations of words that seem, completely fine, but they're subtle enough a person wouldn't know it, but they know that, these are more likely to happen than not if it's used by their system. The other thing is that internally they might do that. So when they collect new data, because they know there's like a blind spot in their system. So let's say they find that it's not very good at, I don't know, generating poems, which is sort of not true. It's kind of mind-blowing how good it is. But let's say that, they find that it's not good for that. Well, okay, well, they might be like, let's generate a bunch of poems that we think are good. Well, not everyone's a poet, so that expertise is maybe hard to get. So maybe we'll start by having it generate a few, like a bunch of them, and then maybe it's just easier to have someone go over these, make corrections, and then you feed this back. So intentionally, you would sort of feed corrected synthetic data into the training. And I'm sure there's some of that as well that happens. And in some ways, that's like perfect feedback because implicitly is directly a signal that you were doing this other thing before, but it was not correct. You should do that instead, right? And I mean, generally speaking, that's sort of how we learn a lot of things too. But yeah, great question. Yep.
I would like to come back to the trust question, I think, which is very important. So I use different models of AI for all kinds of things.
Yep.
Sometimes I ask questions I know the answer to. Is protein A related to protein B, and are these two proteins involved in, let's say, DNA repair? And then there's a text and literature given. And then I click and find the paper is not the right one. It's a wrong information. And this is not true for every model. So there are different models that give you the correct information. I don't know. I don't tell you which one. You take another AI application.
I don't mind which one it is, but
you take another AI application and the literature is not the right one. So I knew what I gave in. I knew it's wrong. But how can I be, what's the way out of this? This is very dangerous. If I ask a question I don't know the answer to and I get literature that I'm relying to and it's not correct. So that is, how do you go out? What's the solution for that? What's the reason for that?
So I mean, generally speaking, what is interesting here is that you already had a signal, which is it's just not the right source. Now, the general public, they might not be able to know that. What they might be able to know is that, is this the right source for that information? And I think this is where like AI literacy is very important too, or numerical, or literacy numérique, digital literacy. So understanding that, there's a bunch of garbage on the internet. Like that's already true if you Google. That's already like a thing that I think the public in general needs to learn to handle.
That's not what I mean. I ask a question, I get an answer by text, and there is a literature reference, which is taking me to...
Oh, it's like a fake? It's not even a paper?
Which is taking me to PubMed with authors and journal. You look this up. It's not correct. It's the authors of another paper in another journal with a mix of other authors. So it's giving me a bona fide literature reference. I click on it. I can. I go to, it takes me to PubMed, which is a PMID number. I take this number, go to PubMed, and it's not what it says. So that's a problem, isn't it?
Yeah, this would fall in the category of errors that we call hallucinations that you might have heard of. It's an odd term for it. I think a better term that I've heard is confabulation, which I feel, I don't know, you might debate it's not better, but and that is a real problem. That is this is something that all of these LM providers are very much aware of. Like they usually track the hallucination rate. In this setting, if it made up a citation that is not even a real paper, effectively, like there are mistakes in it. In this case, that's a pretty bad mistake. If however, but that in some ways that should be verifiable because you can sort of check, well, the information is given about this paper and this title, these authors. Is there a paper with these authors? And so the good thing is that you can sort of check, okay, well, is this like consistent or coherent? So that would be one signal, if I talk to a public in general, I'd be like, if it's giving you a reference, like, are there things that are odd about that reference? And the odder the reference that's given or the consistency or lack thereof of that, the less you should trust it. And I think this is part, again, going back to AI literacy, I think this is part of like people being aware that you should check this, and there are a few tricks that one can use. And one of them is that, like Google after, okay, well, where does it come from exactly? It says it comes from that, but does it really? And for certain things, like it's not the worst thing in the world, but obviously for medical questions, it is. I think generally speaking, in fact, like Google would probably not advise you to, or other systems, to use it for very sort of critical medical advice. And I think this is where you probably want companies that specialize into really focusing on that use case because it is more particularly critical. So I know that Google has a med LM sort of system that's meant to be specialized and tested with like doctors and so on. I would probably be, more keen to trust that than I would a general system that's meant to be used to either generate poems or answer health questions. So that's sort of how I would, approach that. But generally speaking, the right mindset when you're using this is to be suspicious. I think that's just like how you should approach that. Much like if you go on social media, you should be suspicious of pretty much anything you see there and sort of find a source that you trust that can confirm it. Yep.
Hi, following up on being suspicious, then I'm just wondering in terms of like our own personal intellectual input, digital literacy, if we're checking everything anyway, then how is AI helping us? Because if I have to think about, like, go through the primary literature myself, and even in non-scientific context, for example, my daughter at school, she was looking up the family tree of a historical figure, and I got completely wrong because of the naming conventions of the time, the junior, the senior, invented three brothers and, so forth. So then we had to go back to the historical sources. So the thing is, I guess I'm wondering where are the gains if we're still having to do our own homework?
Yeah, I think depending on the area, like there might be fewer gains and maybe the technology for that particular use case is just not where it is. And, there should be hopefully technological developments that either from the base model itself, where it might get better for everything, or just specialized companies that in this particular type of work, we really sort of specialize that system. We'll start from what we have that has a lot of general knowledge, but then we'll just push it and drive it forward and have it be more reliable. There are ways where, I guess I'll go to like some of the things I use it for, and then you can sort of judge for yourself if that'd be useful for you. But one thing that I generally tend to find it useful is that just to critique my own writing or my own answer to a question, to get feedback. My personal preference on thinking about these tools is really as an assistant. So not really there to replace me, but there to sort of assist me and fill in the sort of holes in my workflow, or the fact that I only have so much time that I can spend on any given task. So that would be one. I'm also, me personally, someone who doesn't write particularly fast. I have tended to find that this gives me a pretty good first draft for writing a lot of things. But so this is a tool that, and if you hear out from the CEOs of these companies, they will tell you, because they're CEOs of companies, that will solve everything and they'll be really excited about it. That's their job. That's not surprising that they're doing that. The reality is that, we're going to make some progress. The progress is going to be unequal in different areas of our society, of our industries, and so on. And I think it's more like a question of revisiting this. Okay, well, if it's not good for you now, 6 months later, checking out again, is it useful now? Maybe it is, maybe it isn't, and so on. So that's how I approach it. I don't know who's first, but yes, you? Okay.
Okay, great, thanks. So, with some AI interfaces, you can get a paid account and you have the option of not having your input used to train the model. So I'm wondering if there's a lot of users that do that, and presumably maybe the level of usage is different or deeper, and therefore the model's not being trained with this kind of input. How is that skewing the training of the model? Is therefore you're selecting or you're biasing the model towards an input that's perhaps, I don't want to say less sophisticated, but maybe less diverse, less deep in certain domains? Is that being mitigated, or is the data actually from paid account users being still used in a way that's behind the scenes and we're not aware of?
So on that question, I can only go from what these companies are saying that they're doing, which I have no reason to think that it's not the case. But generally speaking, for me, that becomes important if I want to feed it a document that's like confidential. And I want it to help me analyze it, but I definitely don't want it to be used in some shape or form to inform the next model, just to make sure that none of that information goes through. Looking at Stefan, because he's at MILA as well, and is sort of on top of things like that. So I wanted to know that I use it only with the paid version, where everything stays confidential. I mean, that might be a consideration, that indeed there's sort of a difference in the training distribution. This is where, in some fields where most data might be confidential, this is where a specialized system that's really meant for your use case might become more valuable. Because you sort of can't count as much on the system improving year after year, because it doesn't see as much of that type of data. That being said, that's in general, these companies are faced with we have a huge amount of data and we need to figure out the right balance. So it's an issue anyways, I would say. And then the way they tackle that is they'll have a bunch of different benchmarks in that sort of assesses how accurate, precise, how little hallucination you get in a bunch of different fields for coding, for math, and they'll have a bunch of these. And they sort of essentially use that as a snapshot, as do we have the right distribution or not? And then they make some choices. They might say, right now I think we'll favor coding and math for some reason, because they're computer scientists maybe. But they might track, okay, we know we have a blind spot here. Next time when we will collect more of that data for the next generation. So that's sort of the kind of thinking that I imagine they're doing.
So when we use some kind of a generative AI to generate some text, there is some kind of a particular patterns in them. So is that pattern because of the training set biased, or is it some kind of something else?
Do you mean the pattern I mentioned to detect that it might come from an AI? Just generally speaking, the fact that sometimes we think we can guess that it comes from an AI, and so the latter. I mean, certainly everything that these systems know comes from the data. That's, it comes more or less from nowhere else. In some ways, the specifications of the details of the brain, as I mentioned, has some influence. It's much harder to control for that, though, and have a sort of understanding how changing the nature of the brain will change semantically the type of outputs you're getting. And so all of these systems are sort of different, probably because they're collecting data slightly differently, and they are emphasizing particular ways of framing or answering a question. There's another component I'm not really going to touch on, but there's another way of influencing what you're seeing, which is sort of called prompt engineering, I guess, which is to say, well, for instance, when you're using ChatGPT, it seems like you're starting a conversation from scratch, but behind the scene, there's like a lot of text that is being put by OpenAI, and that's true for Gemini with Google and so on, that will sort of say, generally speaking, what kind of assistant are you, and how do you tend to sort of express yourself? And that text that we never see, that will also be part of designing, adjusting the behavior that you're seeing and sort of improving it based on feedback and so on. That one is much faster because that's something you can edit live and you immediately see a change in the way it expresses itself. So that will also influence. So it's not so much in the data, it's a little bit controllable. It's the technical term for that is the system prompt. And there they might be doing things like, don't always agree, but present two sides, or, these kind of things that sometimes you might see in a system or sometimes you might not. That is probably something that is influenced by that system prompt, but that is generally not shared. This is also part of the sort of commercial secret of how these systems work. Well, last question, and then I'll move forward and I'll get some more questions later.
So the question here is, so it still goes back to the, I guess, the trust. So there is one thing when the system sends you to a reference that doesn't make sense to the question that asked. But the other thing is that sometimes seems like the system has gone completely rogue. It gives you completely wrong answers and it just keeps building on it. Sometimes it has been examples. It has been examples that the system appears to promote self-harms to a person who asked the question and just keeps doing it. So it brings me to the question of whether or not there is or there should be some sort of checks and balances, if not built to the system, but from someone who is constantly on watch and prevents of system apparently taking a very dark turns, taking a very dark turn in providing the answers to the questions.
Yeah. No, it's a great question. And I mean, I think it's very timely. We've seen some recent events that, is a consequence of that. And I am sure there are some attempts at detecting these types of conversations and actually sort of stopping them. I think the reality right now is that it's not perfect. I can't really state on are they doing enough or not, in the sense of how sort of inevitable this was. I mean, everything suggests that they should be doing more. There was a period where, in particular, this has happened with ChatGPT, where it had, for some reason, I don't know if they fully understand, but it was more sycophantic, flagorneur in French. This is a word I learned because of ChatGPT. I know that word. And it tended to always agree, essentially. Which you might, if you don't know everything is going to happen after and these sort of bad use cases, you might think, well, that's good. I like when people agree with me. Sometimes that's more helpful than not. I think they sort of found out, well, actually, this has this other, consequence. I am almost sure that they are doing some attempt at detecting, is someone having suicidal thoughts or things like that. I think the question is I mean, I don't know how much effort they actually put into it. And it's really on them to kind of respond to that. And again, to me, I go back to the importance of, I mean, this is why I speak, this is a specialized crowd, but the reason why I want to talk widely to the public is that people need to know that these things are not they're not fully reliable. They're not even entities, they're simulations. You just faced as a system that simulates someone talking to you, but it's not really someone. And sometimes the simulation is really good, and sometimes the simulation is not all that great, right? And being aware of that when you get into using these systems, I think is a basic thing that everyone, should know. And I think at the minimum right now, in terms of what we can do, us that we're not really behind sort of controlling the way they're deploying that technology, I think that at a minimum is something that we should be aware of. We should be talking about it, between ourselves and our families and so on. So that's if I have one advice of things where we at least feel like we can do something, that's definitely in move in the right direction. Yeah. Okay, so I'll move forward, but these are all great questions. I'll mention very briefly that in terms of doing work, this is where we'll jump to, like in particular scientific work. There is evidence that it's very useful in some situations. Ethan Mollick, which is someone I'd recommend following if you want to have someone who comments regularly on the developments of these systems. He has a blog. He's also a professor. He's at a management school. And he did this study where they took professionals from Procter & Gamble, so a consumer goods company, and have them sort of try to develop ideas for products. And they did it in 4 different conditions. One is just a single person trying to sort of do that exercise, a team, but without any AI, an individual that gets to use ChatGPT, I think in this case, or a team that also has access to ChatGPT. And the main result is that an individual with an AI is essentially statistically as good as a team that has no AI. So that sort of seems to fit with like the idea that this can be used as an effective assistant, like someone, a peer that's working with you and making you more productive or accurate, or which is a great sign. Now, this is true in this area and other areas. You'll see sort of this person in particular likes to describe these AI assistants as having a jagged edge. So if you think of like, imagine there's like a circle, and from the circle, there's like different fields or capabilities like coding and math and health and the environment and so on. And then you think like the more you expand, the more accurate the model is. Well, it's not a full nice circle. It sort of like goes up and down depending on the field. And every time there's a new system, we sort of are not, usually everything sort of moves up, but not necessarily. So in that field for this kind of problem, it looks like it's to a point where it's pretty useful. And for other things, like certain types of scientific tasks, sometimes it is, sometimes it isn't. So let's talk about that specifically. The first few examples that I share are things that I use myself and I find helpful. So one that these systems are quite good at is summarizing a paper. I will say like there are papers that I need to read anyways, so I won't use that for that. But there are papers that are like, sort of close to what I do. It's not critical to everything that I do, to the research that I do, but I would like to have some awareness of what's going on, because maybe later on it might inspire me. And maybe in any case, I just really need mostly a summary of the information that's in there. You can already use these systems already. I think you can upload a file, ask a summary, and that generally tends to work fairly well. One of the tools that I use a lot that does this and more is Notebook LM. Again, this is a Google product because I was at Google and I like Google. But I think if not now, some of these are pretty specific to Google, but I expect if not now, like the other systems have that as well. So you can get a textual summary in the chat. But one thing I really, really like is also get a audio summary. And it has in particular this feature that actually produces a audio summary in the form of a podcast. Now, have you listened to like an extract of that? And I use that a lot for things that, again, like I don't think I have or need to read the full detail of the paper, and I want to know the gist of it. So I'm aware that it's in there. There's some work that does that. You can also have a slide presentation with a voiceover. I actually used this with Jean-François because I was trying to understand what kind of presentation he wanted. So I put a bunch of paper. I asked Notebook LM to summarize this into a presentation just to make it more visible. I shared it with it like, does that seem all right? And then he gave me some feedback, which I hopefully successfully integrated into my presentation. And for someone who has to give a lot of presentations, and sometimes I kind of don't know what's expected, this is starting to prove to be a useful tool for that. I'm gonna try to show you how this works. Okay, so this is the tool. If you visit Notebook LM, if you Google it, you'll find it. You can add one source, in this case, this AI co-scientist paper, which I will talk about later on. That's kind of why it's there. And it'll give you already just by default a summary. You can ask it questions if you want. I don't use that feature all that much. Again, I usually use the audio summary and the video summary. So we'll start with the audio when there's some silence. All right. No, that sounds like not a good thing. Okay.
Imagine trying to navigate, I don't know, a scientific ocean, not just
That's the podcast.
every single day. These huge waves.
This is not a real person.
New research papers, new data breakthroughs, without just getting completely buried. That impossible task, this breadth and depth conundrum, that's really what we're tackling head on in today's deep dive.
And it's precisely why what we're about to explore is, well,
Okay, anyways. So the next one, sorry for the I'm making it hard for the audio person. But I'm going to play the next thing. I'll show you just a sample of what it can look like as a slide presentation. Like that. Okay.
What if you had a research partner that never sleeps, that's read basically every scientific paper ever? And this new AI system gets the exact same problem. And just 2 days later, it comes up with the exact same ideas from.
All right, so it has all of these nice slides, nicer than I can make them. It's usually pretty short. I mean, it's a very high level summary. But again, the goal here for me is just to get like get a sense of what a presentation might look like. And this is something I only recently started to use. The podcast thing I use a lot. Like it's kind of my favorite podcast in some ways because it's perfectly tailored to me. I get to pick a bunch of things I really want to understand a bit better, at least have awareness of that it's out there. So, and then if I need like the actual details, like if it's really, really important, then I'll go to the paper and actually look at the details. So that's how I use it. Okay. Any questions on that? Yes. Yes, over there.
I guess my concern with things like that is the nuance between tool and crutch. So you're using it, for example, to set up a first draft of a paper that you're then going to write yourself and go in and correct it all, compared to somebody who maybe never really learned to write a paper and therefore is completely using AI to do all of the work for them. So I'm just wondering, I guess there's probably something to do with digital literacy and learning how to use these tools properly so that it's not just, well, I'm getting them to do all the work. I don't actually have to even turn on my brain. I'm not going to go through. I'm not going to check if this is valid. I'm just going to put it out there. That's what we're hearing with the colleges. And, you know, students no longer working, they're basically saying, you know, ChatGPT, write this paper for me, and they submit it, and they don't actually learn. So I'm just wondering, how do we deal with that? So what can we put in place that'll permit us to be able to use AI as a tool rather than as a crutch so that we don't learn, we just apply?
Yep. No, that's a great question and a completely valid concern. I'll mention a few things. I mentioned Ethan Mollick. He has a book. I'll mention that at the end. But in addition to being a researcher interested in this space, he also teaches. And he uses it quite a bit in his class. And I'll tell you some of the things that he's found helpful to sort of integrate it. But because essentially the solution is to train people to use it correctly, like any tool, really. So what might this mean? One of them is in his class, there are certain homeworks that he knows there's no way the student can actually do this homework unless they use ChatGPT. And presumably he has to revisit that because it gets better every year. But the idea is really to push them to sort of use it correctly. So that's one part of the solution. I mean, it shouldn't, not all homework should be like that, but I think maybe some assignments should be. The other thing is that you start not only inspecting the output of what a student produces, but you start inspecting the process. So, for example, something fairly simple, like a way to start doing that would be if you were sharing or producing as your homework, like something like a Google Doc or I don't know how the Microsoft Doc works, sorry. But I keep repeating because I feel bad because it sounds like almost an advert, and that's not my intention. If you have like a doc like that, it will have an history of edits. If someone just pasted the whole text and that's all you have, that's like an indication that maybe there wasn't a whole lot of, editing involved. But if you do have the history of edits, and maybe it starts with a big thing and then there are changes, and then as maybe an educator, you can actually inspect that. That is probably where you can start giving some very valuable feedback on how they actually inspected it. So, and there might be more specialized tools that might come up, because I think in education, that's a very valid concern. And I'm also, Irene, personally, certainly very mindful of the fact that this is disrupting this work quite a bit. So they should have support, to help with this kind of work as well. But I suspect also, like, they want to help, they want to be part of the solution for making sure that, their students are well equipped to use these tools correctly. So those are some of like the approaches that I think might help with teaching people to use it well. Like most things, really, like you need someone to show you and teach you how to use it correctly. But great question. Okay, continue moving forward. I would assume I could go until 12:30. I don't know if that's, I got like a minor yes, but okay. Okay, another thing, another feature that's useful is it's called deep research. You'll have it in either ChatGPT, Claude, or Google. I think for Claude it's just called search or research. This is one where you don't really know the piece of work that you want to summarize, but you have an idea of like a topic, and you wanted to go essentially on the web, collect a bunch of sources, and summarize those for you into a report. So for example, when I decided I was going to be doing this talk, I might have asked Deep Research, can you create a report on the state of AI and how people use AI as a scientist? And I'm actually going to show you what I did more specifically. I did a bit more than that. So let me just go up. So in this case, I actually already knew the type of topics I was going to touch on. So I added a bit more than that. I said, okay, well, this paper is really interesting, so we should probably cover that. This other work is quite interesting, so I think you should probably cover it, and so on. So my prompt ended up being like fairly long because I had a good sense of what I was going to talk about. And I did try to have it give me slides. That did not work. I would not advocate for that. This is what you're seeing here. Instead, I'll show you the report, which is pretty long. It has some tables, some places. It brought up some things that weren't on my mind that I hadn't thought about potentially integrating, which was useful. And it gives you at the end a bunch of references where it found them. It's not perfect, but I found like as a first way of getting into a topic, it's actually pretty fast and useful. So I actually sometimes just use it out of curiosity, like a little bit like the podcast. I have this topic I know nothing about. I'd just like to read a detailed long text about it and what's the state of it. And you can then take that document and feed it to NotebookLM and ask it to generate you a podcast and listen to it as well, which I also sometimes do. But okay, so that's one tool that I do find useful. And then, okay, well, we have like just one paper, summarize it, a high-level question, summarize it. Okay, well, summarize it and maybe start writing part of my paper. So write the literature review, for instance. I wanted to mention this one because it comes from researchers at MILA. It's called LitLM. I'll show a demo of it very briefly. The way it essentially works is you give your abstract of your work, and then it will give you some tooling to help you write the related work. I'm going to just play the demo here and talk over it. If you can look it up online if you want to use it as well. But usually it starts with your abstract. Then it will do some search on the web over a number of different articles that are available. And then eventually it's going to give you a list. And then you get to inspect that. And you get to determine, okay, this one's good. This one's not really related. This one's good. So you get to pick which ones. And then eventually you could go straight to generating the related work. That works okay, but so the paper behind the system worked on a better way of generating the related work to avoid, for instance, things like hallucinated citations that we talked about. So, sort of doing a bit more work instead of just saying generate, a related work section. It was more like systematic in the way you ask, okay, now talk about this paper and only 2 sentences, and talk about this other paper, only 2 sentences. And then doing that, they found actually reduced the hallucination rate quite a bit. And again, generally, like this is a tool where you can sort of interact with it. You can make some interventions, generate some more, which is really, I think, the way that ultimately you should be using it. Okay. All right. So these are some tools that I think, given all the caveats that I mentioned about, really when it's really important, reviewing the output and so on, are actually quite useful and that I use regularly. And now we'll talk about a little bit more of the future. And some of the more bleeding edge things that people are exploring, but I wouldn't say, or at least some of them, there's no like super obvious evidence that, yeah, this is reliable and you should use it in this way. It's more like a topic for research in AI, for instance. Okay, so the AI co-scientist paper I mentioned before, so this is what I'm going to talk about now. So we talked about AI systems that could generate some text. They had also the ability of maybe searching on the web. I should say, I haven't mentioned it, but it's also really good at generating code. This is maybe the best application right now of these systems. A lot of people use it very regularly. Again, still inspecting the code, that's very good, but there's a lot of just based on how people are using it, a lot of it suggests that it's very good at a lot of coding tasks that are kind of tedious and mundane and that you'd rather automate. But so good at generating text, doing some searches, maybe generating some code. Now we're gonna, and this has led to a new trend in AI systems that you might have heard about, which is these agentic systems. Agentic is sort of the word that's sometimes used, or the term agent. When we say agent, we usually refer to it as an AI system that can take some action. So searching the web would be a form of action, but there might be other ways in which it interacts with the web. And typically right now, these agents, they really are only in virtual worlds. We don't have, I mean, there's some work in robotics where we're starting to see agents that might take some actions in the real world, but I'm not going to talk about that. So, so one aspect of the work of a scientist is to generate hypotheses to test. Okay, this is, if anything, the very, very beginning of our work for a new project. And so this is a collaboration between folks at Stanford and Google. They generated this, they created this system, this AI co-scientist, that is going to be an agentic system. So the way it's going to work is that a scientist will come in and sort of state out a research goal. So one example that, and you can go read it out online if you want, in either the paper or the blog post that comes with it. This is one research goal that they played with and experimented with. Suggest an existing drug that could be repurposed for AML treatment and provide experimentally testable concentrations for an IC50 Again, none of this makes sense to me. I'm just reading out loud. Perhaps it makes sense to you. I will say that they did that. They used this as an example. It did provide some suggestions, and the research says that experimentally it was validated. So this is kind of a successful example of how it was used. Now, the AI scientist in this case is not going to be just one AI system in some way, but it's going to have a lot of components, a lot of different agents that are going to talk to one another in a way to try to sort of represent what does the process of coming up with hypotheses to test looks like at a high level. So I'm going to, and this is going to be very, very high level, just to be clear, but I'm going to go over them because I find them interesting. So to start, the research goal expressed in, say, 1 or 2 sentences is going to be framed out into a more precise plan. And now, based on that plan, there's going to be what they call the generation agent that's going to generate a bunch of potential hypotheses to test related to that research goal. Then there's going to be what they call a reflection agent. So the reflection agent is a reviewer, essentially. It's going to look at each hypothesis and make a comment about, is this really novel? Is this even testable? Is this interesting? Sort of comment on that. there's going to be a what they call a ranking agent. So that ranking agent is going to take all the different hypotheses that are on the table and is going to compare pairs of them and see which ones are better, and sort of run a sort of tournament where the things that keep winning and being better than the other hypotheses are going to go at the top. So it's, visually you can think of like, you have essentially a room of scientists, and there's some that put post-its on like the board, and there's a ranking agent that just like keeps looking at them and ranks the ones at the top that they find is more interesting. The evolution agent will take the highest ranking hypotheses and try to determine, okay, well, is there like a version of this but slightly different that's even better? So just take one that looks good, but maybe there's a way of drafting a new one inspired from this one that's better. And the proximity agent, it takes, say, pairs of hypotheses, and they're like, well, they're essentially the same thing. They're very similar. We could just merge that into just one. That's what it does. So it's one removes post-its, or a couple of post-its to put new ones, and the other one adds some that are inspired by other post-its. And then there's a meta review agent that has like a higher level view of all the discussion that's happening between these agents and trying to identify trends that are sort of shared across this general movement of this kind of brainstorming that's happening. And all while this is happening, the scientists can sort of intervene. They can see an hypothesis and be like, actually, this is good, but actually, I think inspired from that, I would maybe suggest this one. So the scientists can sort of add post-it themselves. Not literal post-it, just writing on a computer, but and that's essentially the system. And each of these agents, they can look on the web to sort of take inspiration as well, or make some verification about novelty and things like that. So right now, this is not a system that's usable for everyone. As far as I know, you need to sort of ask access for it. They're going with what they call a trusted tester kind of phase. But they, in their research, so right now it's really mostly like a research paper, this particular system, they have evidence that this can be quite helpful. So that's one component where we might eventually see these systems being helpful. Another one that I think is very exciting and interesting is replicating experiments. So people are probably familiar with what's often called the reproducibility crisis. So the observation that too often that we like, some results that are being published, other labs try to replicate it and they're not successful. And we certainly face that in many parts of sciences. We do face it in machine learning and AI as well. And so people at Princeton have started looking into whether AI systems could help with that part. Because I think most of the time, and it's certainly true in machine learning, people are not so much interested at doing the work of replicating someone else's work unless it's useful for them. And we also find that when they find that it's not, or when it doesn't work as well as they thought it would, this kind of work tends to be difficult to publish. So in some ways, like our ecosystem, sadly, is not rewarding that as much as perhaps we'd like. So I view this type of work as trying to, well, maybe we should just have like an AI system do that, because it's clearly something we kind of don't want to do. So if we can have an assistant do it for us, that'd be ideal. So in this case, they looked at agents that would take a code repository from some numerical analysis that some lab has made, and then it would just give it an instruction. So take this particular script and run it. This is a script in R. And then answer questions from the result of the analysis. For instance, say something about this particular plot that was produced, or say something about the correlation between some variables. So you give that to some agent. It sits in what's called a virtual machine because it's coding and it's taking some actions that you want to sort of make sure it's in a sandbox, so it doesn't actually like bug your computer or whatever. So that's what the virtual machine refers to here. And so they have this benchmark. They keep tracking like how good the latest system are at doing this type of work. Right now, I think the most in this benchmark, the accuracy is still fairly low, probably too low to be useful, like at 50%, but it's been going up. So you can imagine that eventually this might be helpful for that. And I think, generally speaking, that should improve the quality of our science. Like, to me, this be a good, positive contribution. Another one, scientific review. So if I had to pick one task as a scientist that, I don't know about your field, but in my field that people dislike the most, I think it's scientific review. I mean, it's very important. This is critical to, the scientific method. But people hate doing that. So that's already a sign that, okay, maybe like having some help with AIs, that might be a welcome sort of improvement. And some people have started to look at whether we're actually ready for that. I would say the answer is essentially not quite yet. But there's this paper, it was published at New England Journal of Medicine, where they essentially looked at comparing the types of reviews you would get from a system based on, say, ChatGPT versus reviews made by actual researchers. It's pretty straightforward. They have a system that takes the PDF, parses its text, and then it asks it, okay, well, can you produce a draft of a high quality review outline? And then you provide all the content from the PDF, from the paper, and then it sort of tells it, okay, so you should talk about the significance and novelty. You should talk about the reasons why it should be accepted, some reasons for why it should not be accepted, and what are the key reasons, and so on and so forth. And that will produce text that's in the format of the review you wanted. And then they did some analysis comparing those with that of real researchers. They did for a machine learning conference and did it for Nature papers, so from other fields. And so the key result is that right now they find that if they try to analyze the kind of points that are raised by review from a ChatGPT-based system or from human reviews, they get an overlap, say for Nature journal papers, of about 30%. But if you take any two different human reviewers and look at how much overlap there is, you get something kind of similar, 28.58%. Okay, it doesn't say that, I should say, like, this does not necessarily mean that it's a good or super useful review, but it is kind of interesting to see that the overlap is similar. So that's already kind of interesting. The other thing is they did ask the authors, if you had this review as feedback on your work, is that useful? And I think it says half of them found it either helpful or very helpful. Interestingly, like most of them find it more helpful than at least some human reviewers. But this goes back to one of the questions I had, which is like, sometimes I can't really trust what's there. So what's the point? Well, one use case might be just to criticize your own work and forcing you to ask yourself different questions about what you just produced. And I think generally speaking, that's, largely a positive development, I would say. Yes.
Did they compare the similarity between two AI reviewers? Because I've tried what you suggest, and most of the people suggest, which is the summary of a paper. So I upload the PDF, and they give me a very good summary, but it was very basic. So when you open it and you actually look at the figures, you can see there are things first missing in the text from the authors, so AI will not catch it. And second, of course, they're missed from the summary. So and that part is a very good as summary, as a basic, but you need to go deeper. So I was wondering, because there is variability from human reviewer, because we see things differently. What about AI, between AI and AI?
So that's a good question. There are ways of generating more to having, if you ask a question twice, there are ways to get more or less diverse answers. It's the technical term would be to sort of change what we call the temperature when you're sampling from that model. So you could have it sample what is approximately the most likely thing that a simulated person would say, or there is like, well, try to sample from the real, large distribution of things that a simulated person might say, and so depending on that, you might get more or less diversity. You'll probably get more diversity if you ask two different AI systems instead, which is probably more helpful as well. But you will get, some variation. And some of that is also just due of like numerical stability. Some of the numerical errors in the calculation that's made in generating this text, they accumulate. So sometimes at some point, there's just a difference numerically. So, good question. Yes.
Okay. It's more a question about when these tools are developed and made, is there people from the field of the focus group implicated in it, or are they only there to test it? Is it during the process? Is there
So I can't say for sure, but I suspect that this one here, which is a pretty specialized system, so it's not like ChatGPT or Gemini overall. It's just like it's a layer on top of in this case Gemini. I suspect that there were researchers sort of involved in designing some of the ideas here. Sometimes it is, I think the easiest way to contribute to this system is to provide data. It's just like a standardized interface for anyone to contribute to this system, which is to say, well, you know what, like if I wanted to ask this question, this is the answer that I would like. If it did, this would be useful to me, right? So you will have like, sometimes, just by virtue of the fact that this data is available on the web, but sometimes actually they'll just recruit, experts and ask them, okay, like, can you solve these problems for us so we can include that into our training process? For math, for instance, you might have heard like recently, 2 of these AI systems won the gold medal at the International Math Olympiad. I think a lot of that was due to probably, that's my suspicion, having collected, a lot of that specialized data probably by talking with mathematicians. That would be my guess. And so that's sort of a way that you can sort of steer to make sure the future version of that system is actually helpful. Now, if you were to design a very specialized system, then I would assume, like for instance, any research that's dedicated to the use in the area of health, generally speaking, I think there's like some doctors that are involved. There's someone from that profession that are involved. So it's not just assessing it, it is also contributing to what the model knows. And I think there are contributions of that nature as well. Yeah.
Say that if you run something through and the answer you get is, it's incorrect, is it our responsibility then to answer back and say, well, I believe the right answer is blah, blah, blah?
There are ways of providing that feedback. Trying to think if it's your responsibility. I mean, if you want to do it, I think that's a good thing, but do you have to? I mean, I think it would be fine for you to say, well, isn't that their problem to solve? I think that's also a legitimate sort of reaction to it, but you can do that if you want. That's usually accessible in some way. If you're using, it depends on the conditions of the system. There are paid versions, like the ones that you might have at a company or an institution. That one usually, I mean, I don't know if there are ways you can do that, but like it will say it will not train on your data. So there you would assume that it would not happen. If you use the free tier, normally, I mean, you should check with like, there's like legalese around this. I don't know it by heart for each of these systems, but generally speaking, they try to improve their system based on what people are providing. I have seen Anthropic that provides Claude, which is another one of these top systems. I think recently they've enabled the possibility for someone to declare that they want Anthropic to train on the data that they provide, so be able to opt in. So that's something where I think they're the first company to sort of do that in a way that's kind of explicit in this way. Because sometimes the companies might not really train on your data, but more look at, like you've shared the fact that you didn't like this answer. So next time, do we generate something that's better or something like that? Yes.
I use Mejima for interpretation. And since the model, we usually have benchmarks to evaluate the model.
Right.
So, and those models, maybe all of the data they train.
Yeah.
Could we trust the benchmark
Mhm.
the model puts out? 98% interpreting X-ray or 98%
Mhm.
of this kind? Or should we have our own benchmark?
Yeah.
In the internet, so we can evaluate the model based on our own benchmark.
So just in case online it wasn't heard. So the question is, these systems usually they have benchmark. You're talking about Medgema, I think you said, and they report numbers, how good they are on these benchmarks. But sometimes these benchmarks are on the web, so they might have trained on these benchmarks. Maybe they've seen these exact questions already. And that is a very, very good question. It's a legitimate concern that these numbers sometimes might be inflated. This is something we debate, I think, a lot in our community. So having your own sort of benchmark that you never release and you just keep it there because you want to track, and one, it's going to be specific to your use case, so it's way more valuable possibly than most other benchmark, but also, yeah, it's not accessible to these companies, so they cannot quote unquote cheat. I think is a very good practice. If you really want to track, have a good sense of how much progress is actually made on problems you care about and that are truly novel, I would definitely advise that. Yeah.
Yeah, sure. But one thing, and Medjima is still progressing about it. So I had my own benchmark, and the newer model, they score better.
Yeah. No, that's a valid point. And there's a lot of debate around to what extent we can trust these numbers. I sometimes kind of don't know. I'm always a bit sort of resistant to trust them entirely. Okay, I'll take one last question and then I'll try to wrap up. Yeah.
Hi, my name is Tabi. I'm an admin assistant here. I just wanted to ask one question about confidentiality, because there is a lot of comments about us being observed by those information that we are gathering by ChatGPT, by Meta, by everything. And sometimes I find it a little bit strange that you can have access to all that information still being observed, because it's a lot of information. I don't know who will follow up about those questions we're asking, for example, to answer, like you were saying about looking for some article and comparing them. And if somebody wants to follow what we were doing, is it possible to be hacked that way? Because I find it surprising, though.
So the information that's accessible is normally publicly accessible. And then whenever a company maybe has access of some private data, then normally, I mean, and they would have like a policy that will disclose exactly what they do. I can mention, again, I'll mention Google, but just because that's the case that I know, when you are paying, so a company that comes in and have like a Drive account, and they have a sort of a professional workspace, and you should you'll be able to find that information online. Like I will say, we will not train on your data. You're paying for this service, so we don't expect you to be providing us with data as part of it. Now every service is going to be different, but generally speaking, like the expectation is that this is, if it's doing a search, like it's doing a search on the web, like anyone would, and so on. But I think there's a lot in your question, like you talk about, say, Facebook, like it's an entire different sort of, it has an entire different set of answers, like, and which I wouldn't know, like what information on Facebook about you is available and such. So I wouldn't be able to answer that. But for these ChatGPT based systems, what I can say is that the free tier, some of that information, like they do say they might use it to improve. And for usually the paid tier, they don't. A good question. It's a valid concern to keep in mind for anything you use, I would say.
And I just have a last comment, because I'm a big talker. I just wanted to say that when you were presenting about the evaluation of information that we're getting, there is a certain hierarchy of information, and then we get the best. But at some point, it seems like that the AI is a tool. It's not something that will do our job. At some point, we will have to use our personal brain. And we have to also use the evaluation of all the information we're receiving and gather everything together and wrap up. There is nothing that will be ending the work of the human being, right?
I mean, my vision of this is that this is meant to serve us and make our lives better. So I agree with that.
So it's a tool that serves us.
I mean, that's what drives, my interest in this area, for sure. There are some interesting parallels to be made also with being a manager versus being an individual contributor here as well. I will say, when I started being a manager at Google, like my coding skills, they did go down. Like I was mostly not coding, it was mostly my employees coding. But that is something also we kind of accept. Like we accept the fact that, well, we rely on our manager to have like the broader picture, and this is the best contribution to our working environment. Might there be a time where some of the work that we think of individual contributions becomes something that's more accessible and doesn't necessarily require a person, and everyone can kind of become their own manager of their own team? I mean, maybe that'd be a good thing. Like there are parts of computer science that today you would have a hard time finding an expert in, like things related to compilation of code. Like I think it's something that, I mean, there are some people, but it's much less common because there's kind of less demand for that. We have compilers that work well. So certainly as a society, like we'll have to make some decisions as to who does what. But certainly my expectation and my desire is that there's always like us part of that. So okay, I should move forward because I'm at time. I said that. And peering even more in the future, briefly, I talked about, well, maybe we can generate hypotheses, and then maybe it can generate some code, and then maybe it can run experiments and from these experiments actually produce a paper, and then it can review that paper. And then maybe that starts being a loop where it sort of runs its experiments and then improves its hypotheses for the next one and start, actually handling the full cycle. And we have some people in machine learning that are sort of trying to see whether that's actually doable. There's even this year a conference where a lot of the submissions are expected to come with at least a heavy use of AI systems and the reviewing as well. So I'm just saying, by the way, I'm saying this, I'm not saying like you should agree with whether that's good or bad, by the way. I'm just telling you this exists. You should know that some people are thinking about that. So, that's something to pay attention to. A large diversity of ringtones. This is very interesting. I like that one. That's my jam. I like it. All right. So, it goes back to the question, which I think there's like, a lot of that behind some of the questions, which is actually how should we use it? I think a lot of that is sort of a collective decision, really. There's not one person out to decide. And there are valid concerns as to why AI maybe sometimes should not be appropriate. I'm going to point to this one. It's a blog post by these researchers from Princeton. They actually have like a series of blogs. They're really, really interesting. And they're asking the question whether instead of accelerating, which we might think it would, could it actually slow it down? And I'll just end with some of certainly these thoughts when I think about what are the pros and cons. I mentioned for me, like the goal largely is to provide an assistant and really make me more productive and allow me to achieve more things that I would otherwise. Certainly like mundane tasks that I don't really like doing, if I could, get effectively an AI intern to do that for me, that'd be great. AI as an intern is definitely a model for me, just because what it means is that when using a ChatGPT, like an intern, it might surprise you and be awesome. It might also be disappointing and be like, okay, well, it's an intern. It's still learning. I sort of need to sort of train it a little bit more. I think that's not a bad mindset to have when you're using those things. As a constructive critic, I think we already covered that. I think it is helpful for that. I use it sometimes, and especially when you're about to send an angry email, I think it's a very good idea to ask whether you framed what you wanted to say correctly. But, and that's part of from that blog post I mentioned, could we get an inundation of potentially faulty science where we don't really have a good sense of whether all of it is done correctly or not? And the role of science is not just to produce papers, like it's to produce an understanding of our world, of our reality. So if we just have a black box that takes an input like an hypothesis and just produces a paper, well, we want to know what's going on inside it, and we want to make sure we understand it, because that's how we're going to trust it and how we ultimately are going to leverage that knowledge correctly. So I think these are the two thoughts that I have in my head when I sort of think about how we move forward in using AI for science. And hopefully some things interesting for you to discuss during lunch. And this is the book from Ethan Mollick that I mentioned. It's pretty quick. It gives you a still fairly high level, but quite useful overview of these systems and how he uses it in his teaching, in his research, in his day-to-day life. I think it's pretty good, and you can follow him online. And that's it. That's it. I can stick around for like 15 minutes if you also want to talk to me after.
Thank you so much for your talk. It was really enlightening for the scientific part. I will not go into science. I have a political question.
Yeah.
I am an artistic person on the side, and I know now they can do movies, they can produce music, and it's like you said, you cannot distinguish as a human being if it's done by AI or not. And now problem is we are really capitalist, and we are going to cut jobs on the creative side to replace by AI. And is there policies that are in place? Is there ethical committees that are investigating this to protect the human creativity?
Yeah, it's a good question. And certainly, at least for me, ultimately, I want these tools to be considered a positive contribution to the various spheres of our society. I mean, there are basic copyright laws, that do apply here. It is a little bit of an unknown, as I'll just describe you the landscape without necessarily putting judgment, because in some ways I don't feel I'm the right person to comment on that, because I'm neither an artist. I am a computer scientist, but honestly, I don't mind if people don't use it for certain things. To me, this is meant to be helpful. So on one side, the side of these companies, sometimes they'll try to make a case that training on some artistic content is a form of what's called fair use. This is you might say I'm gonna say bullshit, because that's probably like something you know more about. But so cut me if I'm embarrassing myself. And so the question is, does that apply? That is, training on data that might be copyrighted to have a system that can generate potentially new forms of art, of movies and so on. Is that fair use or not? As part of fair use, there's, is it transformative enough? And also a component of is it disruptive, too disruptive to that industry? The first one, I think, as to whether it's transformative enough, like something you can potentially kind of judge. I find the other component, which is it going to be disruptive to the industry, to be a little bit hard to judge, because who knows, maybe there'll be even more artists because of that. We've seen automation sometimes leading to more jobs and not less. So it's really, really hard to predict. But I think at a minimum, artists should be part of that decision in some way. And then there are other things, which is, I mean, there are parts of copyright that just apply. And this is, a lot of these cases are going through the legal system in the US. So I would certainly pay attention to that. I think in the end, probably there should be some sort of compensation if that happens. What form it should be, how high, I don't really know. The ideal outcome is that people see that as sort of being beneficial for their field. That this is, not replacing this, but this is more like a new tool, like when the electric guitar was invented, and it was very different from other thing, and it's a technological artifact that was actually led to way more creativity. So that's a good question.
No last question. So I'm going to conclude to say that I think you made all the community think in all kind of way about AI. I think it's fascinating. I'm happy you came at the beginning of your mandate, and we can share a relation and keep MILA close to us. I think we share a lot of similar interests and values. And I thank everybody for participating, and Hugo being open to take questions as we go. It's kind of challenging to give a seminar like this. So anybody who gives seminar, I can tell you this is very difficult. And it was very good. So thank you very much.
Sure, thank you.